Are you able to hear me?
Yes, sir.
Yes, sir. Okay. So shall we get started? So listen. So you know what topic we are going to discuss today, right? It's going to be relations and functions. What is the topic? Yes. Relations and so even before we proceed, can someone tell me what are all the topics you have for your boards? So in this chapter, what do you have?
So reflexive, transitive, symmetric is there.
Okay. You
One to and on is there.
have different kinds of relations and functions, right? So what are all the deleted parts?
Composite functions.
You don't have composite functions. At the same time, you don't have inverse of a function. Okay. But as I told you, we need to discuss them as well. See, but I'm not going to go in depth into those topics. I'm only going to concentrate on problems related to the different kinds of relations and functions. Okay. Maybe I'll just give you a slight overview of the composition of functions because we need to understand the inverse of the function for the next chapter. Right. So first we'll get started. Can someone tell me? If I ask you to give me the simplified version of this whole concept of relations and functions, what will you tell? If I have to explain the whole concept of relations and functions in just one line, how I do is, see, first, I will have two sets, right? So between two sets that are given to you, what is the operation you can perform between them? You will perform something called as A cross B. What is A cross B? It's called as the Cartesian product. So when you do A cross B, what is going to be the output of it? It will be ordered pair, right? So this ordered pair will tell you whether this operation is going to give you a relation or a function, right? So one thing I'm able to understand is whenever you want to understand the different kinds of relations or different kinds of functions, the first thing that starts with the collection of all those elements in the form of a set. And what will you do to those sets? You'll perform the Cartesian product. When you perform the Cartesian product, the ordered pair will come out, which is further going to give you the information related to whether that particular operation is going to give you a relation or a function. So what is the difference between both? So if we can be little quick in our discussion, right, we can concentrate more on problems. So can someone tell me what is the difference between a relation and a function? What happened? Are you able to hear me or not? Why no one is answering? No one knows the answer. At least try, no? So what is the difference between a relation and a function?
So relation relates any element in set A and any element in set B. Function is a relation in which an element in set A has a unique image in set B.
That's right. So, can you tell me slightly? I'll give you an option. Okay. So instead of using the word elements, I'll use the word input and output. If I do A cross B, all the elements that belong to the first set are called as the input set. So basically, what do we do with respect to a function? Right. So if we need to understand function, first I'll come with the reverse. If I need to understand function, I need to understand what is the relation. If I need to understand relation, I need to understand what is an ordered pair. Right. For me to understand ordered pair, I need to know what is Cartesian product, for which I need to know what are sets. So if I do A cross B, this is going to be the first set and B is going to be the second set, right? So the set of first elements, can I call it as input set? Because this is where we are taking the values and trying to give it to a function. And what is the output set going to be? That is B. This is going to be the output set. So if I say, when I give one input, if there is a possibility of me getting multiple outputs, right? I'll give one input, but if I get multiple outputs, then that kind of an operation can be called as a relation. Then what is the function? If I give one input, I should get only one output. So that input elements are what are called as pre-image elements, and the output elements are called as the image elements. That is why when you say for every element, there should be a unique image, then it becomes a function. For one element, if there is more than one image that is existing, then it will become a relation. So functions are special kinds of relations. So having this in mind, let's try to just go through the topics slightly on a faster note. If there is any doubt, please stop me. Okay. So if I have a relation R to be defined from an non-empty set A to a non-empty set B, then it is going to be the subset of the Cartesian product A cross B, right? So how is the subset derived? By describing the relation between the first element and the second element of the ordered pairs in A cross B, right? So the set of all first elements in a relation. So if I write a relation R as something like this, 1, 2, 2, 3, 3, 4, so on like this. Okay. So what does the first element? The set of the first elements represents the domain, and the set of second elements, which we call it as images, right? So set of all second elements. So second elements are given a name called images, and that set is given a name called as range, right? I hope this is clear. So for example, if I take 1, 2, minus 2, 3, half and 3, then what is going to be the domain? Domain is going to be 1, 2, half, and range is going to be 2, 3, right? So when you write a relation, generally, how can you write that relation? You can write it either in the roster form or the set builder form, or you can also use an arrow diagram to have a better visual representation. And lastly, if the number of elements in set A are P and the number of elements in set B are Q, then the number of elements in the Cartesian product set A cross B is going to be P multiplied with Q. And how many relations are possible from set A to set B? They are going to be 2 power PQ. Okay, these many number of relations are possible. Okay, this is all about relations. I didn't speak about functions at all. Right. So the concept that I told you here is from your 11th standard actually. If you guys observe, it is from 11th standard. Now I want to see how many of you have learned it properly to tell me what is the change you observed in 12th standard for you to define the different kinds of relations. What change happens, and that happens, that change is something to do with the first line of the slide. First line of the slide. So you told me about the different kinds of relations. No, what are the different kinds of relations? Reflexive, symmetric, and transitive, right? So for you to define those relations, how do you define the Cartesian product? Let me see how many of you know this or observe. Nitish, can you tell me?
Sir, that element should belong to that set.
Good, in the first line, particular. The relation, you read the first line. A relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product set A cross B. Correct?
Yes, sir.
12th standard le eppadi irukum? How do you define reflexive, symmetric, or transitive? How do the definitions go?
So we
A
take relation from set A to set A itself.
That's it. That is what I was expecting. So when you talk about the reflexive, symmetric, or transitive, right? You don't have two different sets. Rather, you will operate a relation from a set to itself. So in your 12th standard, there is no Cartesian product like A cross B. It is always A cross A. There is no set B at all. There will be only one set, and you do the Cartesian product of elements from that set to itself. Okay. So that is the first important point we need to note. Okay. So in this slide, I'm going to just explain you on how the different kinds of relations can be expressed in a set builder form, right? So suppose I take A to be the set of students of class 12 of a school and B to be the set of students of class 12, class 11 of the same school. Then some of the examples of relation from A to B are, so how do you write them? What are the elements of a relation? What are the elements of a relation? So this A comma B is an element of the relation. But what does an A comma B represent? It represents the
Cartesian product.
Ordered pair.
ordered pair. So when I say Cartesian product, listen to this, don't have this confusion. Cartesian product, now you write all the elements. But what is a relation? The relation is a subset of that Cartesian product. So on the Cartesian product set, what will you have? You will have set of ordered pairs. So what I did to write it in the set builder form is a relation is going to exist as A comma B such that, okay, A comma B that belongs to means that A comma B ordered pair is taken from whom? Taken from the Cartesian product set A cross B such that what is the relation between the first element and the second element of the ordered pair? A is the brother of B. Correct?
Yes, sir.
Similarly, what is going to be the second relation? Now understand. Second ordered pair A comma B is derived from the Cartesian product A cross B such that A is the sister of B. So like this, you can keep writing the relation in the set builder form. So when you look at the, I'll call it as nomenclature. Okay, when you look at the writing structure of set builder form for a relation, how do you do that? R will be equal to, how do we do that? Can you give a form to it? First, what will you write? You'll open the braces, you'll write the ordered pair that belongs to
A cross B.
Cartesian product colon that is such that you write the statement here. Can I say that this is going to be the generic way of writing a relation? Can I say that? So if you understand this, half of the headache is gone. You'll
Yes,
be
sir.
able to write any relation on your own. Right? Shall I proceed?
Yes, sir.
So, as I mentioned in the beginning, in this chapter, we'll study different types of relations and functions. We'll talk about the composition of functions, invertible functions, and binary operations. These parts are deleted, so we are going to discuss only different kinds of relations and functions. Trust me, problems are going to be very simple. Okay. So, as I mentioned in the beginning, listen. we would like to study different types of relations. Okay. But we know that a relation in set A, this is how all the statements start. When I say a relation in a set A means it is the subset of the Cartesian product of that set with itself. Right. So from this, right, when you define a Cartesian product of a set A, there are two extreme relations that you can get. One relation is a right. One relation is going to be a null set, and the other relation will have the universal set. Right. That is why they told empty set and A cross A are going to be two extreme relations. For example, let's take a small example and understand. Suppose I consider a relation R in set A. Okay. So set A is going to be 1, 2, 3, 4, such that I am defining a relation R like this. R is equal to ordered pair A comma B. Okay, where is it coming from? Belongs to
A cross.
A cross A, such that I am saying A minus B is equal to 10. So what is the meaning? I gave you a set A 1, 2, 3, 4. You give me a relation of ordered pairs, relation which contains the ordered pair, such that the difference between the first number of the ordered pair and the second number of the ordered pair should be a 10. Is it possible?
No, sir.
No. So what kind of a relation will this become? So what would be the ordered pairs present in this? It is going to be an
Null set.
empty
Null
set.
set.
Null set. It's an empty set. That's not possible. Whereas, if I give you another relation, I'm stating it like this. You give me the ordered pairs from the numbers that I gave you. Okay. Belongs to A cross A such that the magnitude of A minus B is greater than or equal to 0. Possible. Huh? So if I
Yes,
say,
sir.
yes, it is no. So greater than or equal to 0 also, it is possible. So what will happen? This set is going to be every
Universal.
element, right? Every element is possible. All right. So what is going to be the answer? It will be a universal set. Guys, are you able to visualize it? Okay. Don't memorize, are you able to visualize? Yes or no? These are all very small concepts only, but they're important. I've seen people getting confused here. This will happen in the exam hall. Is it clear?
Yes, sir.
Okay. So this is where the proper definitions are given. See, I need to teach you the definition because I don't know how the MCQs are going to come. If it is going to be a direct definition, you need to have a clarity on it. So listen, a relation is given a name, capital R. A relation R in set A means A cross B is said to be an empty relation if no element of A is related to any other element of A. Okay. So R is equal to null set, but it is also a subset of A cross A such that no element of A is related to another element of A. So this is the first definition according to your NCERT. I hope it's clear.
Yes, sir.
Next. When can you call that relation to be a universal relation? A relation R in a set A is called as universal relation if every element of A is related to every element of A. So R is equal to A cross A. So what you can say, though these are called as extreme relation, it has a special name. Both the empty relation and universal relations are sometimes called as trivial relations. Okay? Everything is a part of your NCERT. All the definitions are taken from there. Here, I'm going to do an example. This is also your textbook problem only. Let's do it little fast, so that we can do some interesting problems. I've taken some good questions. Okay, if I can have more interaction, I'll go little fast, or else I'll feel that you're not able to understand. That's why I'll get dragged. you can interact, it will be better, right? So let A be set of all students of a boys' school. Show that the relation R in set A given by R is equal to A comma B such that A is a sister of B. What kind of relation is this? Even without thinking, you will tell me. What kind of a relation is this?
Empty relation.
Null
It's an
set.
empty relation because what kind of a school is it? It's a boys' school. So boys' school cannot have sisters. Right. Similarly, what about R dash? So R dash is ordered pair such that the difference between heights of A and B is less than 3 meters. What kind of a relation is this?
Universal.
Universal.
Because if you take the difference between any two heights, it is definitely going to be less than 3 meters. So it's a universal relation, A cross A. Right. So the next important relation that we need to discuss, right, which is having a very significant role in mathematics, is called as an equivalence relation. I'm sure everybody would have heard this term. But to understand equivalence relation, we need to consider 3 other types of relations named as reflexive, symmetric, and transitive. Okay. So what are they? Reflexive, symmetric, and transitive. Let's go one by one. So definition number 3. So a relation R in set A is called as reflexive under what circumstance? Can you give me a simpler definition to it? So relation R in set A is said to be reflexive if in that relation,
An element of set is related to itself.
I can say an element of set A is mapped to itself. Okay. Or can I say that the ordered pair is going to be in such a way that both the numbers are going to be the same?
Sir, can we say like if each element is related to itself?
That is also right. So all of different ways of understanding what everybody is saying is right. So a relation R is said to be reflexive if I have. So how am I going to write it? R is equal to, I have the ordered pair in such a way that the first element of the ordered pair and the second element of the ordered pair are going to be the same. And where are they coming from? And they come from the A belongs to A. Sorry. For every value of A that comes from the set capital A. Right. So when is it said to be symmetric? When is it said to be symmetric? If I have an ordered pair A1 comma A2 that belongs to R, right? So when this element I am able to find it in R, if I am able to find the reverse process also, like if I am able to find the exact reverse of it, if I am able to find A2 comma A1 also belonging to the same set R, such that the elements of the ordered pair are coming from where? They are coming from the set A. Okay. So what is happening is, listen to the statement very carefully. If A1 comma A2 belongs to R, if it's a double F, if A1 comma A2 belongs to R, then it is a must condition that you should be able to find A2 comma A1 also that belongs to R. Okay, you should be able to find A2 comma A1 also that belongs to R for that particular relation to be called as symmetric. Okay. And what is the third type of relation? If I am able to find A1 comma A2 that belongs to R, and if I am able to find A2 comma A3 also that belongs to R, then what should I be able to find? I should be able to find A1 comma A3 also that belongs to R, where all the 3 elements A1, A2 and A3 come from the same set A. Is this point clear? If you are clear with this, half of the chapter is over. Are you clear?
Yes, sir.
Yes, sir.
Yes, sir.
Good. So if a relation in set A is going to be reflexive, symmetric and transitive at the same time, then it is called as an equivalence relation. having this in mind,
Sir,
let us look at this example. This is also NCERT one. Let's do it little fast. Let L be set of all lines in a plane. So there are multiple lines in a plane, and R is a relation defined on the set L such that I have R is equal to, what do I have? I have ordered as L1 comma L2 such that L1 is perpendicular to L2. So what is L1? L1 is the first element of the ordered pair. L2 is the second element of the ordered pair. So if I write such relation, then is it going to be symmetric, reflexive, or transitive? So they have already told, show that R is symmetric. So how can we do that, guys? Can someone give me the statement of how you are going to write it in the exam?
sir, for symmetric,
First of all, why can't it be reflexive? Like,
sir, no line can be perpendicular.
No
to-
lines can be perpendicular to each other.
that's it. So L1 comma L1 is not possible because no line can be perpendicular to itself, right? So reflexive is gone. It's not going to work. Then what about symmetry? If I say L1 comma L2 belongs to R, if means I have multiple lines in the plane. I have infinite number of lines. Among those infinite number of lines, if I'm able to find two lines where I name them as L1 comma L2, if L1 is perpendicular to L2, if I'm able to find such a scenario, can I blindly conclude that L2 comma L1 will also be a part of R?
Yes, sir.
Because if first line is perpendicular to second, the second is obviously going to be perpendicular to first, vice versa. That is why they are symmetric. So that is why I'm putting a double F here. If L1 comma L2 belongs to R, means that is an assumption. So when you're writing that if no, it is an assumption. I'm strongly believing that this is true. Then my fate should give me the reverse answer also. Then it will be symmetric. Okay. But why is transitive failing again? If I have L1 comma L2 that belongs to R. Okay, for transitive, how many lines should I take? I need to take 3 lines. If L1 comma L2 belongs to R, and I'm saying L2 comma L3 also belongs to R, is it going to imply that L1 comma L3 will belong to R? So when I say use the word belong to R, you should remember the statement. So L1 is perpendicular to L2. I'm believing that L1 is perpendicular to L2. Then I'm saying L2 is perpendicular to some other line L3. By me saying these two statements, can I conclude that L1 comma L3 is also going to be a part of R?
No.
No,
No,
sir.
sir.
Because
L1 and L3 are parallel lines.
L1 and L3 are going to be parallel to each other. So that is what this diagram is. Right? So I hope you guys are able to understand how to write it in the exam. That is more important. Right? So it does not imply. Right? Similarly, tell me, show that the relation R in the set Z of integers given by R is equal to A comma B such that 2 divides A minus B. So such that 2 divides A minus B is an equivalence relation. So for me to prove equivalence relation, I first need to have reflex. So for me to prove that it is reflexive, what should I do? If I take R, can I take R is equal to A comma A is possible such that 2 divides A minus A. Is it possible?
Yes, sir.
Yes, sir.
Why? Because when you subtract the number from itself, you're going to get 0.
Zero, sir.
So 0, 2 is obviously going to divide then 0. So reflexive, true. Then what about symmetric? R is equal to A1 comma A2 if I'll write it like this. If A1 comma A2 belongs to R. Okay. See, I have a question here. If suppose A1 is greater than A2, then A1 minus A2 will be possible. Have this in your mind. Okay. A1 minus A2 will be possible. So if A1 comma A2 belongs to R, can I confidently say that A2 comma A1 also belongs to R?
Yes, sir.
How?
So even though the sign changes, it's still even numbers. So it still can be divisible by 2.
It can be done. And secondly, they have given the set of integers.
Yes, sir.
Had the same question been, instead of saying set of integers, had they told set of natural numbers. Guys, listen to this carefully. In this question, instead of saying set of integers, had they told set of natural numbers, then what would have happened?
It won't be symmetric.
Then A2 comma A1 cannot be. Can I still define?
Sir, but why wouldn't it still be symmetric? It would
I'm
be,
asking,
right?
I know what is the answer. I want you to be confident and tell
Sir,
me.
it would be symmetric, right?
It could be.
Sir, even if it was natural numbers, they are giving 2 divides A minus B. So
It's
it would still be
symmetric.
symmetric.
That is what I was testing, whether you people are. So it is symmetric. Okay, because what is the statement? It has nothing to do with the sign. What is the statement they gave? 2 divides A minus B. So A minus B can be a positive number or a negative number. So that A minus B doesn't come from the natural number set at all. A comes from the natural number set, B comes from the natural number set. A minus B is only a relation. Are you able to understand? So in this question, you have nothing to do with the integer or the natural number. What about transitive? So what about transitive?
Sir,
Tell me one.
so does it matter from what set the numbers come from? But negative multiple also is valid for any set.
In this problem, it is applicable because they told 2 divides A minus B. So listen to this carefully. When I say, when I'm defining a relation in a set of integers, this ordered pair is there, no? Ordered pair repeller. A is an integer, B is an integer. But
Yes, sir.
the relation, they didn't mention anything. 2 divides A minus B. What is A minus B? They didn't tell A minus B should be a natural number or integer. They didn't mention anything about it. So whether I give you two natural numbers or 2 integers, if I am able to pick up 2 numbers, so yeah, what I'm doing is I take 2 integers. Forget about natural numbers. If when I'm in a statement, I'm taking 2 integers A1 comma A2. So yeah, I am believing that A1 minus A2 is divisible by 2. That is why I wrote if is an assumption by me. It's not a conclusion. If I am able to find A1 minus A2 that belongs to R, can I also say that A2 minus A1 according to the statement belongs to R? Can I say?
Yes, sir.
That's the meaning. So, for example, 2 minus 4, if I take the numbers to be 2 comma 4, for instance, A1 comma A2, if it is 2 minus 4, it is going to be minus 2. Is it divisible by 2? Yes. If this is A1 comma A2, A2 comma A1 will be what?
4 comma 2.
4 comma 2. 4 minus 2, that is 2.
2.
That is also still divisible by 2 only, according to the statement that they have given.
Yes, sir.
So that is why
Okay, sir.
in this problem, it has nothing to do with set of integers or natural numbers, but there are problems where you need to concentrate on them. When we do that, I'll explain. Okay. So, transitive. If I believe A1 comma A2 belongs to R is true, and I'm saying A2 comma A3 also belongs to R is true, from this, can I conclude that A1 comma A3 also belongs to R? You guys think and tell me. Just because it would show that, don't answer the question. You think and tell me.
Yes, sir.
Is it possible?
Yes, sir.
Can you give me examples? See, if at all you're not able to go with the general case, right? You're always allowed to write some numbers that come to your mind. But the numbers you're writing should belong to that set. So A1 comma A2, will tell me numbers. No? Can I write 2 comma 4 belongs to R? And what will I write? 4 comma
4
6
comma
will
6.
4 comma 6. You are free to choose the numbers. Can I conclude that 2 comma 6 also belongs to R? Can
Yes,
I?
sir.
Yes, sir.
Yes, sir.
So it is transitive. Okay.
Sir.
Tell me now.
So in the last question, if we are to prove that by using the general form means we should take the variable, no, sir?
You should take it as 2n, 2n plus 2, 2n plus 4.
Yes.
The complication. I didn't want to go into that. But don't do that also. Okay. See, if you have the knowledge, fine. Example. It's always better to go with safe things. Sorry.
Okay, sir.
So relations we understood. So now the next question is, what are functions? So functions are special types of relations, right? Functions are special types of relation where every element from set A is associated with a unique element in set B. Okay. So if you want to write the simplified version, I'll give you the statement again. Please make a note. Functions are special types of relations where every element of set A is associated with a unique element of set B. Did you write it down? Did you write?
Sir, can you repeat it?
You want me to repeat?
Yes, sir.
Yeah, sure. So functions are special types of relations where every element of set A, okay, is associated with a unique element in set B. Okay. Now, did you write it down? No?
Yes, sir.
Okay.
Thank
Now
you.
I'm going to give you different scenarios. Okay. I'm going to give you different scenarios you're going to answer. A, B, X1, X2, X3, Y1, Y2, Y3, Y4. So X1 is mapped to Y1, X1 is mapped to Y2, X2 is mapped to Y2, and X3 is mapped to Y2. Is this a function?
No, sir.
Why?
No, sir.
X1 has 2 images.
So X1 should be associated only with one element. Okay. I'm erasing this. Is this a function?
Yes, sir.
Yes, sir.
Sir.
Yes, sir.
Okay, if it is a function, what kind of function is this?
1-to-1.
1-1.
1-1.
It's a 1-1
1 to 1.
function. 1-to-1 or 1-1 both in the same. Okay. What kind of function is this?
1-to-1.
It's a 1-to-1 function, but it is not a function at all. Why? Now you read the definition that I
Does
gave.
not have a
Every element of it.
Underline that word every. Every element of set A should have some mapping. Guys, are you able to understand? This is a very, very, very critical point.
Yes, sir.
if one of the elements is also not having a proper mapping, it is not a function. Okay. Now, this one. So I suggest you also draw a separate diagram. Don't draw it like me. I have an option to erase. You keep drawing different sets. I hope you are drawing it along with me. Either function. Is this a function?
Yes,
Huh?
sir.
No, sir.
It's a
Yes, function.
what kind of
It is
function
a
is it?
function.
Many to
What
one.
kind of
Many to one function.
Many to one.
the many to one function? Why is it many to one? Because many elements of set A are mapped to the same element of set B. Can this happen? Yes, it can. Next. X1, X2, X3, Y1, Y2, Y3. Is this a function?
Yes, sir.
Yes, sir.
And what kind of function is this?
1 to 1 and on to.
1 to 1.
One and
On to,
on.
on to. I didn't say what is on to. By the way, what is on to? What is an on to function?
So every element of the codomain should have distinct element.
So what is the mathematical way we write it? Codomain is equal to, we write something like this, no? Codomain is equal to range. That is for the onto function, right? So codomain should be equal to range for onto function. See, I just want to ask this thing. Is there anyone who has not learned this chapter at all, where they have not taught in the school at all? Is there anyone like that? So you guys are familiar with these terms, right?
Yes, sir.
Yes, sir.
Now, what about this one? A and B, X1, X2, X3, and Y1. This is a function.
Yes, sir.
Yes, sir.
Yes, it is. And what kind of function is this?
Many to one.
Is it only many to one?
Yes, sir.
And on to.
It is a many to one and on to. Correct. It's a many to one and on to. Right. So this fine. Okay. So with this knowledge, can we start discussing about the different kinds of functions? So I'll just run you through the concepts and I'll tell you how to solve the problems. So let's say there is a function which is mapped from a set X to set Y. So what does that set X belong to?
Domain.
Set X is the domain. What is set Y?
Codomain.
Range.
It's the codomain. So that will be equal to range only for
Onto function.
It will be a codomain. So f is a function mapped from X to Y, is said to be a one-to-one function, or the technical name for it is injective. Under what scenario? If the images of distinct elements of X under the function f are distinct. So confusing. So what they are saying is, if I have two elements mapped to two other elements such that X1, X2 are two elements which belong to set X, and if at all there is a scenario where X1 and X2 are getting mapped to the same element, that is, if f of X1 is equal to f of X2, then what should be the relation between X1 and X2? X1 and X2 should not be two unique elements, they should be the same element. So that is what the mathematical statement is. Okay. Now tell me what are the steps to be followed to solve problems based on one-to-one function. So what is the first step you are going to do?
Find f of
For
x.
every x1, x2 belong to it.
That's right. So first step is consider x1, x2, which belongs to the domain set. This is consider. Okay, you are considering x1, x2 that belongs to the set capital X. Then find f of x1 and equate it to f of x. Find f of x1, find f of x2, equate both. Then solve the equation. And on solving the equation, if you get x1 is equal to x2, then it is going to be a one-to-one function. If not, it is a many-to-one function. Am I right? So I'll teach you some more techniques also. Listen to this carefully. This is something which you already know. Right? Are you clear, guys?
Yes, sir.
Now listen. So in this question, tell me 30 seconds time. Tell me which is one-to-one function. First one, is it a one-to-one function?
Yeah.
So first is yes.
Yes, sir. Yes, sir.
Second is
No, sir.
No, sir.
third.
No,
No.
sir.
No, sir.
No.
Fourth one.
Yes, sir.
Yes.
Yes,
Yes,
sir.
sir.
That's it. So having this in mind, now I'm going to ask you a question. Okay. So show that the function. So I'll come to the onto function later. First, I want you to answer this question. Oh, observe this clearly. I have a function defined from natural number set to a natural number set. Somebody asked me about the domain and range. No, concentrate here. So there is a function that is mapped from a natural number set to another natural number set. And the function is defined as 2x. Is this a one-to-one function or not? Forget about onto as well. Is this a one-to-one function?
Yes,
So
sir.
how you prove? What are the steps I gave you? Consider x1, x2 that belongs to capital X. Sorry, that belongs to, what should I write in this problem?
N.
Capital X. That is this set.
Domain
X1,
N.
yes. So I'm going to consider f of x1 and equate it to f of x2. That is 2x1 is equal to 2x2. X2 and 2 are getting cancelled. So x1 is equal to x2. So it is a one-to-one function. Okay. Now, I want you guys to think in the reverse and frame a question so that it's not a one-to-one function.
So domain, if you change to Z,
So let there be a function that is mapped from, you give the domain, you give the codomain, everything.
Z integer to integer.
You want integer to integer. So f is a function mapped from z to z. Okay. And define the function.
F of x equal to x square.
X.
Square.
So f of x is equal to x square. Okay. So what will I do? X1, x2 belongs to z. Correct? So I'm considering f of x1 is equal to f of x2. So what will I write? X1 square is equal to x2 square. Then what will I get? X1 is equal to plus or minus x2. So what is happening here? It is a many-to-one function. Okay. Now, see, guys, concentrate. Did you all learn applications of derivatives? Everybody has learned applications of derivatives. Yes or no?
Yes,
I
sir.
need.
Yes, sir.
Okay. So in that applications of derivative, did you guys learn about maxima, minima? About decreasing, increasing functions?
Yes, sir.
Yes. So listen to this. I'm just going to tell you why this chapter is important in calculus. Okay. X, Y, X dash, Y dash. So f of x is equal to 2x. What does it represent? If I ask you to draw the graph for
A
it,
straight line passing through origin.
straight line passing through origin. And what does the 2 represent? It is of which form now?
Slope
Y is equal to mx.
equals to mx plus c. So c is 0.
C is 0. So that's why it is passing through the origin. So any equation in this world which does not have a constant added to it will pass through the origin. Okay. Now, this is how the graph is going to look like. See, use the technique that I'm going to teach you when you need to solve a problem in MCQ. Okay. There is something called as the horizontal line test. What is it? It's called as horizontal line test. Means if I draw a line parallel to x-axis, listen to this. If I draw a line parallel to x-axis, and if that line cuts the curve only at one point, then what kind of a function is this?
1, 1.
It's a 1, 1 function. So in the horizontal line test, if the line cuts the function at only one point, it becomes a 1, 1 function. Okay. So this is not a very big thing. This is not what I wanted to share here. How is it going to, sir, you can ask me, sir, how is it going to help me understand calculus? So when I have a 1, 1 function, no, a 1, 1 function can either be a strictly increasing function or a strictly decreasing function. Does it make sense? Is it right?
Yes, sir.
Yes, sir.
Are you able to visualize what I'm trying to say? When you have an idea about a 1-to-1 function, a 1-to-1 function is always a strictly increasing function or a strictly decreasing function. I know I'm going out of chapter. If the same topic is asked in your calculus and they're asking you to find whether there is an increasing or a decreasing function, what would you do? Forget about the domain and range.
Sir, I have a doubt.
Tell me.
Sir, but the thing which you're saying, it also depends on the codomain, right?
That's why it won't forget. That's why it's typed it off.
Sir, but if we take tan graph, then if we consider the codomain in a particular like set of value, then it
Yeah.
would be 1-to-1. But if we consider the whole graph,
That's the tan is not a 1-to-1. That's right. That's what I'm trying to say now. So it depends on the domain and the range. First of all, this graph itself is wrong, which I drew. Why? F of x is equal to 2x. I should have drawn a graph like this when f is mapped from R to R. Right? When a function is mapped from real number to real number, I should have drawn this graph. So I am trying to say in general. So when you say a function is 1-to-1, right? You have a restricted domain associated with it. That's what we learned in inverse trigonometric function. No? When you say tan x, you use a very good example. You told tan x. Tan x is not a 1-to-1 function, but it is a 1-to-1 function only between -π/2 to π/2. Only when we use restricted domain, we will be able to find the inverse of it. Am I right? But
yes, sir.
in that restricted domain, I'm not talking about anything. So in the restricted domain, I didn't want to speak about it. If in the given domain, if you say that the given function is 1-to-1, okay, if you're able to prove that in the given domain and the range, if the function is 1-to-1, you can blindly conclude saying that it is a strictly increasing or a decreasing function. That is what I'm trying to establish here. Are you able to understand what I'm trying to say?
Yes, sir.
Yes. So here I'm not concentrating on the domain or range guys. If you are able to, so in a problem, mostly if you see in your CBSE part, they would have not given you domain and range. Like when they ask you the increasing and decreasing function, they will ask you across which values the function is going to be increasing or decreasing. Suppose the same question is asked. My point is, how will you solve it? You will find f dash of x, and f dash of x comes out to be 2. So 2 is greater than 0. When something is greater than 0, what will you conclude?
Increasing.
It's an increasing
Increasing
function.
function.
Strictly increasing function. Where is it increasing from? Minus infinity to plus infinity, it is increasing. Minus infinity to plus infinity is R to R. Breathe. So I'm just giving you different perspectives of thinking. That's it. Okay. So again, I'm telling you, apply this concept only to MCQs. This horizontal line test is not a part of your CBSE curriculum, so don't use it. So if they ask you in CBSE, you need to do it as x1 comma x2 belongs to natural number. F of x1 is equal to f of x2. If x1 comes out to be equal to x2, it is 1-to-1. Else, it is many to one. I hope everyone is clear with this fact, right? Yes, sir.
Yes, sir.
Okay. Now the question is about an onto function. So if I have a function that is mapped from x to y, okay, please bear with me for 10 more minutes, we'll finish one. So a function is mapped from x to y is said to be onto or surjective. So it's a technical name. When will it be surjective? If every element of the second set has a pre-image associated. If every element of the second set has a pre-image from set from the first set, then the function is said to be onto. Okay. So tell me, among the four graphs that are given, four arrow diagrams that are given here, which one is onto and which is not?
The
First one.
fourth one is onto.
First one is not onto. Why?
So third and fourth are on.
E and F do not have pre-images. Second is not. Again, E and F do not have. So third is onto.
Third and fourth, sir.
The fourth one?
Fourth one onto.
Onto.
Yes. So first one along with onto, sorry, third one along with onto, what are the function is? It is a
Many to one.
Any2.
any to one and onto. The fourth one is 1-to-1 and
1-to-1 and onto.
so 1-to-1 function and onto function has a special name. What is it called as?
Bijective.
Called bijective function. And a function, see, next chapter is inverse trigonometric functions, right? Remember, you can find the inverse of a function only if the function is bijective in nature. Okay. So if I put a question, is there an inverse possible for the third one? Is there an inverse possible for the
No,
third
sir.
one?
Oh,
Because it's a many to one and onto, whereas for the fourth one, inverse is possible. Okay. So what should you do to prove that a given function is onto? If a function is mapped from x to y, it is said to be onto if the codomain of the function is equal to the range. If codomain is equal to the range, then you say that the function is onto. Okay. Now having this in mind,
Sir.
tell me that.
Sir, third one in the diagram, it is surjective but not injective, right?
Yes. It is onto, but it is not 1-to-1.
Okay, sir.
So that is why what I write it here, you can take a note. It's a many to one and onto. Okay. Now, how will you prove? Okay. So how will you prove that this function is an onto function? So what are the steps to be followed?
Sir, we take y equals to f of x and then we write y in terms of x in terms of y, and then if like the
So
final answer
that
y
is
is
the-
equal to the one.
That's right. So that method is used to find something else also. What is it?
inverse.
It is used to find the inverse and you can find the range also. Okay. So step one is assume, say I'm telling this for people who are new. So assume the function to be y. So y will be equal to 2x. What is step two? Suprajit, you were right, tell me. Right? X in
Sir,
terms
write
of-
x in terms of y.
right? X in terms of y means it implies x is equal to y by 2. What is step 3? What is the verification? This is the
So
verification step.
substitute this x value in f of x.
No need verification error. So what has happened is y is equal to f of x has actually become x is equal to f of y. So what value does y take? This is where the domain and codomain is important. So thus y is equal to 2x, x takes the values from the first set. This is where x takes the values from. And what does y take? Y takes the value from the second set. Means what I'm trying to say is, in the place of this y, if I substitute any natural number, then I should get a natural number.
Yes,
Breathe
sir.
out. Are you able to understand?
Sir,
what I'm
but
trying to
we can directly write f of y by 2 and then equate it. Right?
say? F of y by 2, where will you equate to?
No, sir. F of y by 2 is 2 into y by 2. So that's nothing but y. So we get back the result y. That's how it is on to.
It is not on to. Read the question. It is not on to. It is not an auto function. You should not do that. I'll tell you why. That is why, see, concentrate on what I'm saying. When you're dealing with onto function, for that matter, even for one-to-one function, when you're dealing with function itself, most of the people miss this part of observing the domain and the codomain part. Listen to this. I want an assurance from everyone. Is the first step here? You're doing nothing but taking the function and equating it to y. I hope that is simple. Second step, you're writing x in terms of y. That is also simple. Now, what you need to prove is, what did I tell you onto function is? I didn't give you the book definition. So, if I have to say a given function is onto, for every element that is present in the codomain, there should be a
There should be pre-image existing in X.
correct. So, if a y by 2, listen to this. In the place of y, what can I substitute? What am I allowed to substitute?
Natural
A
number.
natural number.
I'm allowed to substitute only a natural number. For example, if I take a natural number 1, if I substitute 1 here, what am I expected to get?
Half.
Natural
Another
number.
natural number.
I'm supposed to get a natural number, but am I getting a natural number?
No.
No.
So that is why it is not an auto function. So what you can say is, for all values of y, which are odd numbers. So for that matter, see, you don't want to think this complicated. You can write it directly. You can say y is equal to 1, which belongs to the natural number set. There is no pre-image existing. Breathe out. There is no pre-image existing in the natural number set. Can I say this? Can I say this? Is everyone able to understand what I'm trying to say?
Yes,
Say,
sir.
if you're
sir.
able to understand this, is both functions is clear in your hand. So what are all the things you need to concentrate on, which you people miss? You miss
Domain and codomain.
Domain and
domain,
codomain.
codomain. Now I'm going to test you. I'm not changing the function. I'm comfortable with this. F of x is equal to x. I want you guys to change the domain and codomain in such a way that it becomes an onto function.
So real number to real number.
That's right. So if I map the function from real number to real number, observe step 1 and step 2 is the same. Whatever be the domain and the codomain, it is fixed. That verification step here, that is the most important of all. Now, what does this tell me? In the place of y, I can substitute a real number, and what am I expecting back?
Real number.
Real number.
Breathe out. So if I substitute a real number here, I can substitute any number I want. I will definitely get a real number.
Sir, even R to N is possible.
That's what I was about to say next. Good that you thought. So if I take f is mapped from R to N, I wanted to actually first N to R, adukapra R to N panna. Good. So if I do R to N, then what will happen? In the place
It
of
is
y,
onto.
Sir,
It is
tell me,
onto.
tell me that.
sir, but R2N is not even a function, right? In this case.
Right?
Sir, because half of like there are many elements in R which are not mapped.
Oh, sorry. I forgot about it. Yes. So it's not a, but wait. That's right. What he's saying is right. I'm sorry, it is my mistake. So f map from R to N is not actually a function. I was only concentrating on onto. Okay. Why is it so? So did you understand what is the logic he told?
Yes, sir.
So if I substitute a real number, for example, if I substitute 1 by 3 there, I'll get y is equal to 1 by 3. Sorry, 2 by 3. 2 by 3 is actually not a natural number. So the only possibility is R to R.
So N to R is also possible, sir.
Think about it. N to R is not possible. Why?
Sir, in R, there are many elements which are not mapped in N.
See, if this map, for example, if I write N to R, N to R then is one Akash.
Yes, sir.
So real number, I should get a natural number. That meaning,
Sir, the function is possible, sir.
real number, I'll put 1 by 3. So yeah, 1 by 6 was the natural number.
No, sir.
Sir, but the
Purita.
function is possible.
So are you able to understand this domain and codomain game?
Sir,
Solra,
sir, but N to R function is possible.
we are talking about function. Yeah, function is possible. Function is possible, but it is not onto. Here, our context is only for onto.
Yes, sir.
Sir, can you explain why not R to N?
R to N. You want me to explain that?
Yes, sir.
N to R, are you clear?
Yes, sir.
Okay. R to N. So when I did this R to N, what happened is one advantage is I checked only the onto function. So what mistake I did is in the R to N level, in the place of y, I can substitute a natural number. So for example, I substitute any natural number 1, 2, 3, I get a real number, no doubt in that. But logically speaking, it's not a function at all. Why? For example, if it is R and this is N, I'll have a real number 1 by 3. Okay. So x is equal to 1 by 3. What is f of x here? Is it not 2 by 3? Are you able to understand?
Yes, sir.
Okay, sir.
So 2 by 3, what should it be? It should be a part of the codomain. But codomain in the natural number set. In the natural number set, you will not find 2 by 3 at all. Means this 1 by 3 does not have any mapping, so it's not a function at all. Purida.
Yes, sir.
Okay, so this is how we need to concentrate, guys. I think I've taken 10 more minutes. I thought of solving few problems. So next class, what I will do is I'll solve few problems from here, then we'll go to inverse trigonometry. Though I put it as inverse trigonometry, I will solve some problems and then. Okay. So apart from that, everything else is clear. Are you able to think?
Yes,
Yes,
sir.
sir.
Okay, that's good. So I'll see you all in the next class. So yeah, we'll wind up now.
Thank you, sir.
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 Thank you, sir.